Okay, so let's kind of look at a couple examples of how we carry out these computations, because they're really pretty straightforward. Okay, so this is just a two-dimensional vector field. You can see x and y, and we just have these two components, I and j. So it's going from two dimensions into two dimensions. And notice it already gives us the parameterization. Okay, so we're integrating the quarter circle here just from 0 to 5. Okay, so when we set up this integral, we want to find the full work done. So it's going to be integral over c of f of xy dotted with r prime. And so when we switch coordinates, what is f of xy going to kind of look like? When we want to switch that, integrating this with respect to our parameters too. What is f of xy going to look like if we switch to our parameters? So, yeah, so x equals cosine of t, and y equals sine of t. And so f is going to kind of turn into this vector cosine squared t, and then negative cosine t sine t. And we're taking the dot product with r prime of t. So r of t is cosine and sine. R prime of t is going to be negative sine of t, and then cosine of t. Okay, and we're going to just be integrating from 0 to pi over 2. And we can kind of put those bounds now that we switched everything to be in terms of 2. And luckily, I think that this integral is actually going to kind of work out to be relatively straightforward, because we're going to have cosine squared t times negative sine of t, so negative cosine squared t sine of t, and then we have plus, because it's the dot product, but we have this minus here. So we're going to have minus cosine squared t sine of t. dt. Okay? Do you have any ideas about how to carry out that integral? Yeah, we can just do substitution pretty straightforward. Okay, so what is u going to be? U is going to be cosine of t. So du is going to be negative sine of t. And so I think that we're just going to have 2u squared. So 2u squared du. And so that's going to integrate to what, 2/3 u cubed? And can I go ahead and switch back to cosine? Because that's what u was. I'm going to evaluate from 0 to pi over 2. I think cosine of pi over 2 is 0. So it's going to be 0 cubed minus 1 cubed. So I think it's going to work out to just negative 2. This is minus. Okay. On the left, what is it? Yeah, sure. Okay, so, are there any questions about that one? Down, down. Very nice. Yeah. No, so kind of what this is like this is just like kind of the sum of all the work. So this is kind of an independent a unit with. I guess what is work is normally in joules. So, this just has to do with like so in other words this vector field F is like a force field. Maybe it's like a magnetic field or something. And this particle is moving along this quarter circle from here. And if we kind of went through and looked at the vector field, it's x squared, so it's as it goes to the left, they're getting stronger and stronger pointing that way. And so it kind of makes this funny shape, but in general they're pointing to the right, and that's why it ends up being negative, because this particle is going to the left. And so like these vectors, most of these vectors are kind of pointing that way, and so it's kind of negative work. And so all it is kind of the total amount of energy used by that vector field on the particle. Yeah.